So imagine you had two metal plates. One was square, and the square was circumscribed by a circular metal plate. And let's say for now, let's say they're the same material. Let's make it one of these materials. Okay, let's say silver. So let's say the distance from here to here, let's say the radius of the circle is 1 meter. So when I heat both of them up, what's going to happen? At the end, do I expect them to look like this? In other words, do I expect the square to bulge out of the circle? Or do they look like this? With a little gap left here. You see here? So that would be a nice thing. We should be able to calculate that. So if it looks like this, then tell me what that thickness is from here to here, you know? Or you could even calculate this distance. Either one, you should be able to calculate. So by saying the distance, I mean this distance right here, you see, from the edge. If it looks like this, then tell me that distance too, same thing. But now the square is coming out of the circle. Or you could also say this distance, right? So we should be able to use that equation that we have. So let's focus on the square. Oh, let's focus on the circle, since we already know its radius. So the original area is pi times 1 squared. So it's just pi. The final area is going to be the original area plus 2 alpha original area delta t. Okay, and I'm going to give it some change in temperature. So the change in temperature, let's say, is 50 Celsius. So let's say I heat them up by 50 Celsius. So then the A final is going to be what? Original area, which is pi, 2, and then silver I had written is 19 times 10 to the minus 6. Okay, so final area is pi plus 2 times the alpha times pi. Oh, pi because the original area was pi, right? So this is the original area at times the change in temperature.
Was it because 1 squared is just 1? So...
Yeah, it's just 1 squared was just 1.
Okay, thank you.
Yeah. And then now the final area is going to equal pi times the final radius squared. I'm more interested in this problem. I'm more interested in the final radius of the circle. So pi cancels. So now I'm left with our final squared is 1 plus 2 times 19. Okay, let's calculate that. A lot of the calculations you can do with your iPhone tool. You don't necessarily need the scientific calculator. So 1 plus okay, 2 times 19 times 50 times 10 to the power 6 negative. Okay, so that means R final squared 1.0019 meters. Oh, that's R final squared. It's not the radius, so this is actually meters squared. Right? So then R final is going to be what? Square root of 1.0019. You see, because how did this become meters squared? Well, because the area is itself meters squared. And so this is meters squared, this is meters squared, so everything is meters squared. And then at the end, you take the square root of this, then it gives you that. So then you take the calculator, you take the square root of that. Oh, 1.0009, let's say 95 meters. Okay, so that's the new radius. Now let's do the square. Okay, so what's the original area of the square? There's less area, right? So I'm thinking that since it has less area, it's probably going to expand less. Probably this is the more likely scenario that's going to happen, right? It's going to expand less. So that circle is going to expand more, and there's going to be a gap left. I'm thinking that maybe this might happen, but I'm not 100% sure, you know. Okay, so now what is the size of the square? If this is 1, what would be that side of the square from here to here? So if this is 1, this is also 1. So the square looks like this. This is 1. This is 1. Looks like an envelope, huh? What is the side of the square? Daisy, yeah, I mean, you're asking about sig figs. The less rounding you do, probably the better. I could maybe go a couple more decimals. 9.4. Actually, I could just write the whole thing down. 9.4955, and then only round at the end. I'm getting a brain fart. Someone help me here.
Wouldn't it be also 1 because it's an equilateral triangle?
It is an equilateral, right? Is that? I don't know why I'm getting a brain fart. Is
When
that?
When I did a squared plus b squared equals c squared, I got 1.
Oh, you mean if you did? Or is this a 90-degree angle?
Yep.
Yeah, it's a square, right?
Yes.
Why am I getting stuck?
I got square root of 2 then, actually.
Oh, yeah. So then square root of 2, right?
Yep.
Yeah. Okay, I was getting a brain fart there. Okay, so this is a 90-degree angle because it's a square. Okay, 1 square root of 2. Okay, so now from there, we can calculate the original area of the square. Square root of 2 times square root of 2, which would be 2 meters squared. Yeah, you see, that makes sense because the area of the square is less than the area of the circle originally, right? Then we do that whole thing. A final is A initial plus 2 alpha A initial delta T. A final is 2 plus 2 times 19 times 10 to the minus 6 times 2 times 50, right? And then that's going to equal to the final area, which is the final side squared. So here there is no pi to cancel like that, like in the other case. I'm just going to set the final area because since it's a square, it's going to maintain its shape and it's going to end up as a square. Okay, so let's calculate that. 2 plus 2 times 19 times 10 to the power 6 negative times 2 times 50. Okay, so we have final side squared is 2.0038. And then you take the square root of that. Which is going to be 1.41556564, let's say. That's enough. Okay, so now we should be able to solve that. So now if I'm thinking it's probably this here. So from here to here is 1.4155. Oh, okay. So I see what. So if this is the new square, and if this is from here to here is 1.41556564, what's going to be the diagonal of the square from here to here? Then we can compare that to the radius, because the circle's radius we already know is 1.009495. So basically, to figure this out, let's say call it x. We have x squared plus x squared is 1.41556564 squared, which takes us back to this number, right? So this number was even more important than this number for this case, 2.0038, right? So now we have here 2x squared is equal to 2.0038, right? And then we have divide this by 2. Right? That means at the end, they both expand. This one expands and the other one expands. And they're still touching at the corners. That's interesting. Well, you know what happens? So here's what I was assuming. I was assuming since this one is maybe bigger area, it will expand more because its original area is more. And I am right. It's not that I'm wrong. But that doesn't mean just because this expands more, this one will not be touching that. This one doesn't have to expand as much for its diagonal to be continually touching the edge of the circle. Do you see what I'm saying? So what ends up happening is that this guy is not expanding as much as that, but it doesn't need to expand as much as that because its diagonal needs to be, let's see here. As long as its diagonal is keeping up with the radius of the circle, the two sides will be touching. So when this guy expands, so for example, when this guy's original shape was like this, right? So it expanded from here to here. So it didn't expand as much as the circle. The circle was like this. You see? So the circle's area increased by a larger amount than the square's area. But their edges are still touching. You guys get that? I thought their edges wouldn't touch, but it still ends up that their edges touch. Sometimes you get a surprising result like that, but then you try to explain what that means, right?
And the result we got could change if it were a different material, right?
Yeah, if they're different material, oh yeah, that's going to change the whole thing. Then we don't know. Let's see. I can make let's make one of them a different material. So let's make the circle a silver. Let's keep the circle a silver, and let's keep the square. Let's change the square to, let's see, one of the other ones, iron. And in iron, the alpha was 11 times 10 to the minus 6. Okay, now when you expand them, what should happen? Iron will expand less, so of course this will happen, right? This scenario will happen. So how will we know? Well, we'll just go to our equation and we'll change this to 11. 11 times 10 to the minus 6. And then do the whole calculation again. So two plus 2 times 11 times 10 to the power 6 negative times 2 times 50. Okay, so this became 2.022. Okay, so then I don't even need to really find the side. Then I can just say 2.022 divide 2.022 by 2, and then that'll give me what, 1.011, right? Then you square root that, 1.011. So let's divide this by 2 and then square root it. Oh, it's quite different. 1.005498 meters. And then the other one will be this, the radius will be that, right? For the circle. Now if we subtract, oh, okay. So we'll get 1.009 minus 1.0094549,178. Okay, I just did it the other way, but I'll get 0.0003997 meters. And then I'm going to change that. When something is that small, I'm going to change it to like a millimeter or something. So 0.3997 millimeters. That's noticeable, actually. You know, it's something like this. A millimeter is like that. So 0.39 millimeter is like the thickness of this. Yeah, that's noticeable. So the circle will be larger. The circle will be larger like that, and the gap here will be 0.39 millimeters. So it'll be obviously bigger. So then in that case, it ends up that they will have to be different materials for their edges to not touch.